Good morning and welcome to our latest current briefing session, How do we tackle grid integration of clean energy assets? I'm joined today by Ioannis Grammatikakis, the UK Country Manager at Power Factors, who's going to start us off with a presentation before we move into an audience Q&A for the bulk of the session. With that in mind, I'd like to invite you all to put your questions in the question box on the right-hand corner of the screen. Please feel free to add them there at any point during the presentation or during the discussion after, and we'll do our best to get through as many as possible. So without further ado, Ioannis, could you tell us about how we tackle grid integration of clean energy assets?
Thank you, Molly. Thank you for the invitation. I have a small presentation, a few slides that I can share my thoughts about this subject with you, and then I'm very happy to hear the questions from the audience and answer them if I can, of course. So I guess you can see my screen. So we all have seen many headlines about grid integration, how renewable assets affect the grid. So I have just add a few of those headlines in this slide here to show you that the actual constraint in order to allow more capacity, renewable energy capacity into the grid can cost billions of pounds. And at the same time, we have seen, all of us, some events that they were actually a blackout due to some renewable energy assets, and this also has a great cost for the consumer-centered network. So there are actually several grid limitations that can put obstacles at the penetration of renewable energy assets. I list here a few of them. So, of course, first of all, the limited grid capacity, the intermittent nature of the renewable energy assets. This causes problems. Also, there are several weak grids that they have issues with voltage, with frequency, with power. And on top of that, we have to add the fact that many of the renewable energy assets up to now, they don't have, let's say, a very good or the perfect control. So a suboptimal control can also be a problem. Now, the good news is that although they cause problems, renewable assets, they can also help. It can help the grid, it can help the expansion of the grid, and now with the addition of batteries, this is more evident, and we can discuss about this in the few slides. There are also lots of systems. Now we have advanced power plant control. This also helps towards this direction. And market and policy that offer incentives for this penetration of renewable energy assets in order to alleviate the grid problems. I want to touch on those 3 points, but first of all, let us have a quick look of what is the process of the grid integration of renewable energy assets. Okay, so we must always start with a grid code analysis. Grid code can be different. Now we are in a better position that for Europe, we have a common, let's say, grid code. This is the version of this for the UK is G99, but it is the same across the European countries. And as we proceed, we will have a more common approach. But this was not the case in the past, and also there are many other countries with different grid codes. So we have to study the grid code. We have to understand the design of the site and the requirements, all the specification of what is the control functionality that is actually requested, what would be the interface with the grid operator and such. And then we have the system design, the actual installation of the control, the power plant controller, the test of the grid interface, and the testing of the control functions, and finally the grid code integration and testing. So we all understand that this is a lengthy process, and you need some expertise to go through this. Let's see now how renewables can help to ease the grid integration and the grid problem. So here we see that we have different technologies. Now, each one of them, they can offer different services to the grid. So traditional wind farms and solar sites that were in the past just dummy assets sitting there and just pushing electricity to the grid now are smarter. So we have the capability of active power control, so as to lower the supply when the demand is low. We can offer a reactive power in order to support the voltage. We can actually do frequency response with them. And those two assets can be augmented with batteries. And battery storage give more flexibility, make the assets more dispatchable, more controllable. And you can actually implement on top of those functions energy shifting, capacity firming. So things that were easier with traditional conventional power generator. You can then add some conventional gas peaking sites in order to absorb any peak or to add some inertia into the system. Okay, and with this you can form a virtual power plant that has renewables. The main part of the virtual power plant is renewables, solar and wind with batteries, plus some gas-fired power plants in order to absorb some high demand periods. And you can also take advantage of some capacitance banks and the devices in order to be more flexible with the reactive power regulation. And this is the case when you have bigger sites. So we have seen a lot of big solar assets across the world where there is a need there for adding capacitance banks. And you can also add the loads into the mix, and you have some demand response. Okay, all those together can form a smart grid that is that has a lot of renewable energy assets. And here are some examples of this support. So we have the UK market, the FFR, the dynamic containment, FFR in the past, now dynamic containment, dynamic moderation, dynamic regulation. You can see some examples from our system here where you have these services delivered to the grid. And this provides additional revenue streams to the owners, but also stability to the grid. And this will allow higher renewable energy asset penetration to the grid. Another example here comes from, this is a Latin America asset where we perform AVR, automatic voltage regulation, using the reactive power. This specifically is a very weak grid in a rural area, so services like that also they allow the developers to access some lower cost areas for site construction. Combining all of those technologies together, you can form a microgrid, a mini grid, and hybrid power plants. So you can take a full advantage of this smart network, smarter grid that is actually coming as we progress. So the combination of wind, solar, gas power plants with storage and demand response, all of them together without actually investing in without large investment into grid expansion. The second point here is advanced power plant control. Okay, so we need power plant control that can work across the different renewable energy technologies. It can control wind, it can control solar, batteries, and hybrid plants, combination of all those technologies. This needs to be fast, accurate, and steady. And we are now going to offering services down to a few milliseconds with examples from the G99 with a reactive power response of 200 milliseconds, or some services in Ireland, the DS3 regulation with 150 milliseconds. So we are now at this range of response, which is enabled by the combination of the control systems and the newer inverters. You need control systems that are vendor independent, fully interoperable, in order to be able to deploy them in different technologies in different sites. So you don't need to have any problems with specific devices. So full vendor independent, and worldwide compliance. It's another thing that you have to take into consideration once you start doing renewable energy sites across different countries. So you need a control system that is tested across all those different grids. Simulation, power system simulation, very important aspect for the grid stability. Before installing, before the actual construction, you need to prove that what you are going to add into the grid will not cause any system. So the controllers needs to have accurate models that they simulate the behavior of them, and also provide functionality that enhance the grid. So this is done with real-time digital simulation. It's what we call hardware in the loop. So you need some hardware there to emulate the grid, okay, and your own power plant controller, so as to see the combination of all those things, how they work together. And cybersecurity. Now, as we add more and more renewable energy assets into the grid, cybersecurity becomes an issue. And we have, of course, several standards and best practices. So there's the ISO 27001 standard, there's the NERC CIP regulation for North America. So all the processes and the technology exists to actually offer a real cyber secure system. And the final thing, and I will stop so as to hear your question, is how the market and the policymaker can offer incentives, how they can advance this grid integration of the renewable energy assets. And the answer is here with more commercial services. So we transition from day ahead and intraday markets, the normal energy market, and the balancing market, where renewable energy assets and batteries can have a role there, with other markets like frequency response and regulation, like the very good and dynamic market of FFR and DC DMDR in the UK. We are seeing in other areas in the US, there are several states that they introduce also some energy shifting and arbitrage kind of markets, where you have incentives to shift between different days, between different hours of the day when you produce the energy, and several other system services that they come, they start to appear, like virtual inertia, black start procedures, etc. So there is a lot of space for new markets, introduction of new incentives to the market in order to advance all those new, let's say, functionalities. As a summary, so what we see, and we have, let's say, experience for more than 60 countries. We monitor more than 200 gigawatts of installation. So we see that the renewable energy sites, the RES plants, while they used to be a liability to the grid, now they become an asset. Okay, the sites are becoming smarter, more controllable, more predictable. Forecast also helps here. So the power forecast is a very important aspect for the smooth grid integration. And battery energy storage helps to improve the grid stability. It is very important to make those assets more dispatchable. The technology is advancing. We have better control. We have better tools and software to optimize the performance of the site. Very important as well in order to be able to offer the maximum available capacity to the grid and the capability to comply with strict requirements of the global energy market. And last but not least, we are seeing a dynamic market that now offers several incentives to the owners to provide grid services. And those grid services can provide grid stability, improved power quality, and security. So there are a lot of ancillary services and markets that can be used towards this direction. And with this slide, I'm finishing the presentation.
Thank you, Ioannis.
And I will be happy to hear your questions.
Thank you, Ioannis. That was really interesting. Yeah, we've got a few questions in the box already, but if anyone has any others, please do feel free to stick them in. I think we might just be experiencing a minor technical problem with Ioannis, so I will just try and get him back very, very quickly. But yeah, really interesting presentation. So hopefully lots of great questions, and we will get through as many as possible. I saw a couple of people asking about whether or not the slides will be available after. We will send them around in an email, and also keep an eye on the current website, because we will have a write-up of this session that will include an embedded version of the video recording. So if you wanted to look back at anything, you're very welcome to, and always feel free to reach out if you have additional questions following on from the session. Yeah, 2 seconds, hopefully, while we get Ioannis back. Excellent. Yeah, so the first question, Ioannis, from Simon Maloney: how can we unlock more grid capacity to allow more community energy projects to go ahead?
I think the answer here is the way that we are going to allow more integration of renewable energy assets in general. So I don't see that the community projects, they have something special for the grid integration itself. It is more like the way you formulate the market. Okay, it's more the way that the policymaker give incentive for community energy projects, which in my opinion are very important, because it's not only that they give the opportunity to the people to be a part of this, it also give them the thinking of that they are part of this renewable energy revolution, and it helps the penetration in many ways. So for grid capacity, okay, it is what it is. It can be a part of all the renewable energy projects, but incentive for community energy is very important in terms of mainly for this region.
Absolutely. And the next question from Josh Giddings: what do you believe is the one thing that policymakers, domestic developers, and renewable developers should be installing or proposing to improve grid integration?
One thing, yes, very good question. In my opinion, the addition of battery energy storage together with solar, it is the thing that can get the whole renewable energy penetration in the next level. And this can be from very small sites, and we have seen countries like Germany that they have provided several incentives to add batteries into their residential solar. So, and this is a program that runs for many years, I think quite successfully. And this is a paradigm that many other countries can follow. And we also see a lot of installations at the utility scale. We see installations in the UK. We mainly see uh, energy storage sites standalone because the market with the frequency response at the moment, it is more better for standalone uh, installation of batteries. But in other countries like in US, in California, or in Australia, we see more and more big solar projects, utility solar projects, that they are built together with big batteries there. And and this will, allow a lot of new services. And so my point here is that you can go with solar and batteries to existing grids without a lot of investment, from very small sites, from residential sites, with also with commercial and industrial, and up to utility scale.
Fantastic. Next question from Tobias Grag. Are there any particular products or countries that are demonstrating best practice with RES integration or microgrids?
With microgrids, yes. We've seen a lot of installation of microgrids in several African countries, and this is something that is expected more or less because there the grid integration, the grid is not very good. So there are many areas where the grid is almost non-existent, or the grid is very unstable. So there is a clear need to build microgrids, and we see a massive market there, which will also uh, help the people. We, as an example, a few years ago, we were part of an installation of hybrid systems that were with solar, with batteries, and some diesel generators to provide power to university campuses in Nigeria. Uh, and we provide the control there. Very important projects.
Um, Sorry, I think we might have lost Ioannis again. Hopefully he should be back in a matter of seconds.
Hello, can you hear me?
Yes, we can. Sorry to lose you there.
Sorry, I got disconnected. Uh, how I was saying that we see a lot of microgrids in Africa, and I have another very interesting case where we have seen, for example, a lot of microgrid deployments in California for for in order to electrify areas in the national parks there that they suffered a lot of from the wildfire. So they want to provide independent uh, systems that are small microgrids. So there are different cases, but all of them they have a very, very high interest. For in general, for renewable energy uh, sites, wind, solar, etc. Uh, I think that now it's becoming a mainstream. I cannot think of a country that is not a good candidate for a high level of renewable energy penetration. There was a market in Europe that was mainly driven by the government incentives a few years ago. Now it is back without the incentives. We see a lot of installations in Spain, in Italy, in general, but we also see not only in the south of Europe, we'll see a lot of interest in Scandinavia. So it's everywhere. I think together with the whole electrification, I think it's the energy of the future.
Absolutely. The next question is from Anthony James. He said, you mentioned virtual inertia. What are your thoughts on the maximum possible percentage of non-synchronous generation that can be on a grid at any given time?
That's a very good question. And of course, I don't have the answer for that because it is so much grid dependent. So it depends on how the grid is, what are the interconnections. So it is a problem that need to be solved at a very regional level. So for any different grid or part of the grid, the answer will be different. So it is so different, for example, to have a small island that you are alone, or if you have a country in the middle of the continent that you have interconnections with many other countries, and they can offer support if needed. So it is something that depends on a case by case basis.
Okay. And the next question from Kinseya Petrochenov. What are the main regulatory changes that are needed at a national level to accelerate RE integration into the grid?
As I said during my presentation, I think the most important incentive here is to have markets that boost the ancillary services, so as to make it possible to have more assets that they offer those services. So frequency support, voltage support, all those services is very important because, okay, one thing is to sell the energy that we provide, but it is very important to offer the services that can stabilize the grid. If you stabilize the grid, you can add more and more renewable energy systems into the same grid.
And we're coming close to the end of our session, but maybe time for just one more. We have a question from Adam Forsyth, who said, if there is a sufficient very fast response, can we do away with the need for inertia entirely?
Yes and no, in the sense that the very fast response, of course, give the capability to the network operator to operate with very low inertia, but you must also have some redundancy into the grid. Either you can, let's say, risk a blackout, and we have seen blackouts. We have seen the blackout in the UK. We have seen the big blackout in the US a few years ago. This cost billions, or I don't know, but it cost a lot. So at the end of the day, there must be some inertia. But as we progress, and as you said, with very fast response, this can be the traditional, the conventional generation can be smaller and smaller and smaller.
I think that's probably all we have time for, unfortunately. I'd like to thank Ioannis for his presentation and for the Q&A, and thank you to everyone who's tuned in to watch it. We'll have another Current Briefings webinar in the next month or so, which will be announced in the normal way on Current and in emails, so keep your eyes peeled for that. But beyond that, thank you again to Ioannis, and I hope everyone has a lovely Tuesday and a lovely rest of their week. Goodbye.
Thank you very much.